Hi all. Today we'll be discussing how to design a double riveted butt joint. This is a question of a double riveted butt joint with the equal width of core plate. Okay. So butt joint, I think you know all the difference between lap joint and butt joint. Lap joint basically it's just formed by overlapping with each other, but butt joint is side to side. Okay, here you can see. Okay, this is the one plate and this is another plate, and these two plates are joined side by side. But in order to get fixed together, we'll be using some cover plate. Cover plates are placed placed on the top of the both plates to which to be joined. So basically, it is something like to increase the uh, strength or to increase, joining between the uh, plates. Okay, so these two, there is one at the top and there is one at the bottom. These are the two cover plates. They have mentioned this equal width of cover plates. So both the cover plates are having equal width to join two plates. Okay, this is one plate, this is another plate. We have to join these two plates. So not to join these two plates, we'll be using cover plate. So and they mentioned the thickness of the plates, which I have to join is 10 mm. Okay, so thickness of the plates is 10 mm. The allowable stress for the material of the rivet. Okay, these are rivet system, right? So um, various stresses are given. The tensile stress for rivet. Uh, okay, here you can see the rivet will be, sorry, it is not tensile. The rivet is forming compression where the plate is having tension. So what really happens is there will be a force exerted on this opposite side. Equal and opposite force will be applied on this plate. So what really happens is there are various stresses formed in this rivet plate system. The plate will be having a shearing effect. So of course, obviously there will be a tension in the plate. On the other hand, the rivet will be having a sense of compression. That is what I have given. So the plate is in tension. So the tensile stress of the plate is given as 80 megapascal, while the rivet is having a compression, and that stress is given as 120 megapascal. Okay, so the rivet material, obviously when this force are applied, there will be it will fail by shearing. So will break. It will fail across the cross section of the rivet. So the rivet will fail by shearing. So that shear stress is given also given as 60 megapascal. These are the three condition or stresses related to the rivet plate system undergoing a force. Okay, basically we have to design. Design means we have to find certain parameter. Any design question of a riveted joint means we have to find certain terms. That's what they mean. Okay, so let's explain the detailed step-by-step solution. So first, let's write all the given condition. We have a double riveted butt joint. Okay, so we have a double riveted butt joint and thickness is 10 mm and tensile stress, compressive stress, and shear stress is all given. This compressive stress is actually crushing stress. Okay, you can say like that also because the compression is actually that means crushing of the rivet. This tensile stress happen in the plate and crushing stress or compressive stress act in the rivet. And this shear stress act along the cross section of rivet. Okay. And the very first thing we have to determine is the number of rivets in the single shear. Okay, the number of rivets in the single shear, the number of rivets in double shear. So what is single shear and double shear? So this is the front view and top view of this given question. They haven't mentioned whether it is chain riveting or zigzag riveting, just mentioned it as a double riveted butt joint. So how to find the number of rivets in single shear and double shear? So what is single shear and double shear? So this is a front view. You can see this is the front view of the rivet plate system. So basically a force will be applied to this system. That's how we consider the failure and design. We'll be considering that force is applied and based on the different stress developed, we will be designing a rivet system. So when a force is applied, suppose an equal and opposite force, one force along this direction and another force along this direction, it could fail by many ways. It could be by tearing, shearing, crushing. So what we have to find is the number of rivet in the single shear or double shear. Basically, shearing happens at the rivet. So you can see this is the plate we have to join. These two are the plate we have to join. The plate which is placed on the top is a cover plate. Okay. So if we look along the cross, I just consider this rivet along. I will zoom in. So this rivet could fail by shearing at 2 points. One is this part because this dome-like structure is the outer end of the rivet, right? But the plates are at this intersecting at this point, one over here and another over here. Suppose a force is applied along this plate, this plate, this plate. So at this point, the force acting on this plate will be in this direction. It is the force applied on this side. This part will be exerting force on this side, right? So basically, it could have the same case can be applied on all the placed on the either side of the both side of the rivet. So this rivet could fail at this exact this line along this line. So when you consider this rivet, there are 2 point shearing. It could fail by shearing. One at this point, because why you selecting this point? Because we have the plate line along this right. So because due to this plates, it could fail only along this line. So one at this part and other one is this part. So this one rivet could fail by double shear. Okay, one this one and another this one. Suppose we don't have. Just assume we don't have these two plates. Okay, we don't have two plate. I mean, just assume that we don't have the top plate. This rivet will be bit bit smaller. So we'll be basically having a like this two plate. So this rivet will be short and this will be something like this. So in that case, will be only single shear. Why? Because when we consider these two plates, is only a single shear because it could fail only at this point. But here we have two plates. So two plates there are 2 point. It could fail by shear. Okay. So basically, when we are considering a like butt joint, obviously we'll be use cover plate, right? So we cannot obtain single shear. There will be double shear. Just keep that in mind. So how do you like take the number of rivets that are occurring shear? Okay, how do you take that number? So that's mentioned. That is measured by considering the number of rivets by pitching. For that, to consider the number of rivets, we have to consider top view. I haven't mentioned whether it is a zigzag riveting or chain riveting. We are assuming it to be a chain riveting, or we can take by zigzag riveting. Either way, it's correct. So since we have not mentioned it is whether like it's, a zigzag riveting or chain riveting, here it is assumed that as chain riveting. So this will be the top view of this butt joint. Uh, what you have to do is just take the pitch. Pitch is the center to center distance between two rivets along the same row. So we have one rivet over here, one rivet over here, one rivet over. This is one part. Okay, dividing the midline. This is one part of the whole system. This is another part. So if you consider center to center distance, uh, what you have to do is you have to consider this whole line. Okay, center to center, not here. Just check whether there is any rivet on the next row. If you check the next row, you can see same case. Okay, so if you take the pitch, that means center to center, there will be a like 4/2 is included of the four rivet, not the full part, which is basically center to center distance, right, from here to here, here to here. So we have this 1/2, 1/2, this 1/2, 1/2. So 1/2, 1/2, 1, another 1/2, 1/2, 1. So there are total two rivet. This is the way to check the number of rivets or uh, take the number of rivets. First of all, I identify whether it's a single shear or double shear. Since we have three plate and 2 points or two line of action for shearing, obviously it will be a double shear. Next step is to find the number of rivets that are undergoing double shear. We already know it's double shear. We are just the next step is you have to take the number. To take the number, just take one side of this rivet and take the center to center distance and check how many part of the rivets are included along this whole plate. So we have four half of this rivet. So 4 into 1 by 2, 2. So number is 2. That's how we get the number of rivets in double shear. Since it is double shear, with that column is 2. Suppose it is the it could vary on the question. Sometimes it would be single shear, sometimes it will be double shear. So the number could also vary. So this is a way to determine that. So we have number of rivets and double shear into 2. Next step is to basically they are what they asked you to design this double riveted like butt joint. So there are certain parameters we need to find to design. So very first thing is to determine the number of rivets in single shear. We just find out that the first part is over. The second part is to find thickness. We do not want to find thickness because it is already given in the question. So 10 mm which is given. Third part is to determine the diameter of the rivet hole. Okay, diameter of the rivet hole. The very first step is you have to take the unwind formula. So this unwind formula can be found out from the data book. You can check it from the data book. This unwind formula can be found. So based on the unwind formula, to find the diameter of the rivet hole, D is equal to 6.325 root T. So it will be approximately 20 mm. Okay, based on unwind formula, we got the value of diameter of the rivet hole as 20 mm. And this formula you need to by heart. So this formula used when the value of the diameter of the rivet hole by Unwin's formula is between 12 and 24, right? We got 20 mm, which is between 12 and 24. Then we need to use this formula. So this we have to by heart this formula in order to solve this problem. So this relation is not available in the data book. We have to know this relation, that is d is equal to d1 plus 1 mm, and this relation is used only when the diameter of the rivet hole found out by the Unwin's formula is between 12 and 24. So based on this formula, where D1 is the diameter of the rivet and D is the rivet hole. Okay, just keep that in mind. So based on this formula, D1, that is the diameter of the rivet, will be 10 mm, right? We know the value of D, so 20 mm. So obviously 90 mm. These two value, that means the diameter of the rivet hole and diameter of rivet, is not the actual value. Okay, this is based on this formula. We need to find the standard value because there is certain like standard value for designing. You cannot simply choose any value, any number for designing this rivet and rivet hole. So there are certain standard value. So how do you find that standard value? So we have D1 as 90 mm. Next we have to check the data book. Yeah, I will show the data book. So this table can be found out from the data book. You just have to check your data book. So these are the standard diameter of the rivet value. Only based on this diameter value, you can manufacture a rivet. Rivet. Okay, these are the standard value. The by Unwin's formula and by that relation, we got D1 as 90 mm. Where D1 is the diameter of the rivet, right? So you cannot find 19 mm. Okay, 18 is there, 16 is there, 20 is there. We don't have 90. So if you don't have that particular value, what you have to do is you can only use this value in this standard table. You cannot assume any other value. That diameter we have to find only by using this table. Okay, so we have 90 mm as a D1, which is the diameter of the rivet. So next value based on that will according to standard table is 20 mm. You cannot take the value less than. Suppose it will be 18 point something, then you have to take 20. Even if it's 90 point something, you have to take 20. 18.2 means 20. We have to take the next big value. So based on this table, it will be 20, which is the standard value of the diameter of the rivet. So now we got the standard value of the diameter of the rivet. So standard value D1 we got it as 20 mm. So now we got the standard value of diameter. This D1 means rivet, right? We need to find the diameter of the hole. Okay, that is the third step, right? So how do you find diameter of the hole? Just have to use the same relation. This same relation we have to use. Okay, based on this relation, now we got the standard value of T1. So by using this formula, you can find the standard value of hole. So the third part is diameter of the rivet hole. Standard diameter of the rivet hole, which is 21 mm. Okay, D. Now we got the standard diameter. Fourth step in the design process is to find the pitch. There is we need to find two value. One is optimum pitch and maximum pitch. So this optimum pitch, this same formula you can find in the data book. You don't need to by hard disk. Similarly, this maximum which is again this formula is also find the data book. So by substitute we have all these parameter. We know N1 is 0, right? So N2 is 2. We have D which is 21 mm which is found out. Shear stress is given in the question. D we know. T thickness given. Tensile stress is now we have know already know it. So we have all the parameters to substitute this equation. Now the optimum pitch is 180.4 mm. Next we have to find the maximum pitch, which is given by the formula K1T plus 41, which is also in the data book. So how do you find the value of K1? Okay. So based on this table, we'll be finding the value of K1. It's a constant value, the coefficient. Okay. So if you check in the table, this table can be found out from the data book. We have double butt strap, right? So we need to focus only on this table. And the number of rivet per page, we have to compare with this table, this table and the corresponding table based on the row based on the question. We have double bootstrap join, so you have to compare with this one and this one. So number of rivet per pitch, we found out as 2, right? We already found out by that 4 half, we know the value is 2. So the corresponding value is here is 3.50. So this is the value of K1. So now we got the value of K1 based on this table. This table can be found on the data book, right? We don't need to by heart any of these terms. So now we know the value of K1. So we can substitute in this equation and maximum pitch we get as 76 mm. So we have optimum pitch and the maximum pitch. So how do you find this pitch of this rivet plate system? You have to take the minimum value of this tube and assume it as a standard diameter, standard pitch value. So comparing the optimum pitch and maximum pitch, the maximum pitch is having the lower value. So the pitch or standard pitch of this rivet will be, the system will be 76 mm. So that's the way to find the pitch. We have to find optimum pitch and maximum pitch and take the minimum value between them. Okay. Now we got the standard pitch value of 76 mm by taking the minimum value among these two. Next part we have to find is the transverse pitch, which will be 2D in the case of this like butt joint. This value you can find out in the data book, right? So this value can be found out better in the case of chain riveting. Where this is the value we are assuming it to be chain riveting, so we have to take the transverse pitch value as this one. So these all values equations are available in the data book. You don't need to learn any of these equations. Next term we have to find for designing is the margin. So margin is basically the center distance of the rivet to the edge of the plate. Okay. Those who don't know, that's what margin is, which is given by the equation 1.5D. We know the standard diameter of the hole. So substituting, you get the margin value. The final step is to find the efficiency. Actually, efficiency is not asked in the question. Basically, the design and part ends here. Even though some question may ask how to find the efficiency and how does this fail? How does this whole rivet system fail? So that's why I include efficiency. Basically, there are three efficiency: tearing efficiency, shearing efficiency, and crushing efficiency. These are three efficiencies related with the rivet system. First, rivet tearing efficiency, which is given by this equation. For P is the standard pitch, D is the standard diameter. We know about the value. The value will be 72.64%. Shearing or rivet efficiency, which is given by this equation. We know all the values, so simple substitution. It will be 128.2%. The crushing efficiency also we have this formula. This all formula can be find out in the data book. Okay, so we got three efficiency. So we just have to consider the net efficiency as the minimum of these three values. And if they ask how does this rivet system fail, we have to take the efficiency which is having lower value. If we compare these three efficiency, the efficiency having lower value, tearing efficiency, then I can say this rivet system will fail by tearing. Suppose it is shearing efficiency is having a lower value comparing to the other two, tearing and crushing, that means it will fail by shearing. Lower value is the first thing that would happen to the rivet system. That is the way in which it will fail. So based on the efficiency value, the three among these three values, lower value is tearing efficiency. So the rivet system will fail by tearing. Okay, this is the way to solve this problem.